Hello wonderful person, this is Anton, and today we're going to be talking about a very interesting study that identified a very specific asteroid orbiting in the same orbit as Mars that might have potentially come from our own moon. In other words, there's a chance that a chunk of the moon, or essentially a piece of the moon, is orbiting somewhere in the same orbit as Mars. Something that many of us didn't really expect, but it's something that's definitely possible. So let's talk a little bit more about this, starting with this right here, Phobos. Martian moon Phobos, along with its partner Deimos, many scientists believe may have actually come from the asteroid belt. As a matter of fact, they certainly resemble asteroids, and because Mars is the closest planet to the asteroid belt, it would certainly make sense that Mars may have captured one or two of these rocks sometime in its past, although a lot of modern studies suggest that it's very likely that these two rocks may have been actually created through a collision with Mars and may have actually stayed with Mars for a very long time through a very different means. But that's not really the point right now. The point is that having asteroids around Mars should not be a surprise. And many planets, including the most massive planet Jupiter, have always been capturing these asteroids and keeping them in just the right regions of their orbit that we refer to as the Lagrange Points. In this simulation, you'll see that right there, all of these blue and red points, these are different Trojan asteroids of Jupiter, located in these two specific Lagrange points known as L4 and L5, which actually create extremely stable orbital points for any rock to survive in there for billions of years. And in total, there are 5 different Lagrange points that exist in orbit of every planet, and they can be used to position any kind of a body in the orbit of any planet, and this body can be kept in orbit indefinitely without falling into the sun or without colliding with anything in the vicinity. Many Earth satellites, for example, are located in various Lagrange points, with some being present in L4 and L5, and some also being present in L1 if they're trying to study the sun, or L2 if they're trying to look away from the sun. But L4 and L5 Lagrange points are the ones where we usually find a lot of mysterious rocks trapped by gravitational forces. And so, not surprisingly, we have found thousands, and in reality there are probably millions of these Trojans in the orbit of Jupiter. We've also found them around other gas giants, we've found some around our own planet, we've found some around Venus, but we've also found some around Mars. There are potentially 8 different asteroids we've identified so far, and most have been discovered in the last decade or so. And for the most part, all seem to be coming from the same family of asteroids, most likely separated through some sort of a collision billions of years ago. And all of them also seem to share very similar composition, and are overall very similar to this other asteroid also located in the same region known as Eureka. This one, as you can see, also has its own tiny moon, making this one of the binary asteroid systems. And so in this case, it seems that a lot of these asteroids came from the same collision event, most likely with asteroid Eureka, or from essentially some sort of a parent larger rock that fell apart and most likely collided with something. And we kind of think that they all came from the same event because they all seem to contain, for example, things like olivine, which is normally relatively rare in asteroids. Interestingly, Mars, the surface of Mars at least, seems to have a lot of olivine as well, so there is a chance that these asteroids that are now in Martian orbit may have originally come when some kind of an asteroid collided with Mars and expelled large amounts of huge rocks that essentially became the asteroids, many of which later ended up on planet Earth as well. But the recent study that you can also find in the description below identified something unusual about one of these asteroids. The asteroid known as 101429. It doesn't really have a better name just yet. That particular asteroid seemed to possess very different composition, suggesting of course that it probably came from somewhere completely different and was created by some completely different event. By using the Chile's Very Large Telescope and by using a very specific spectrographic technique, they were able to identify the exact composition of the surface of this asteroid, revealing that it was actually full of pyroxene and also somewhat iron-rich as well. And what's really interesting is that this type of a composition is almost exactly identical to what we actually find by looking at certain locations on the surface of our own moon. And it's really not that surprising. If you look at the moon, all of these craters are essentially signs of extremely powerful collisions. Collisions that will normally generate a lot of different rocks flying all over the solar system. Naturally, some pieces will fall back to the moon itself and will actually stay on the surface, But some pieces will end up leaving the moon and eventually end up in other parts of the solar system. Some of these parts could be in Lagrange points of various objects, including of course planet Earth, but also planet Mars. And here's the direct comparison between what seems to be lunar surface in certain parts and of course the rock they've taken a look at. It's obviously not a perfect match, but it is nevertheless extremely similar to what we observe on the moon. And obviously, if this asteroid indeed is a piece of the moon, it would be extremely interesting for us to go there and to try to investigate what sort of other mysteries we can discover by looking at its surface. Although there is still a chance that maybe this asteroid also came from a collision with Mars that somehow came from a different region where there were similar conditions to what we have on the moon today. In other words, the pyroxene and of course iron could have come from some other region on Mars, which is also actually exciting because discovering where this region is could help us discover a potentially important area or potentially important region somewhere on Mars where we could create a functioning colony and of course a functioning mining facility. But also, maybe this is just the effects of weathering for billions of years. Maybe this is what happens to the surface of these various rocks when they're exposed to the extremely powerful radiation from the sun for such a long time. Maybe this is actually what a lot of things will start looking like, and it could actually be something completely natural, something that does not need a collision with the moon or a collision with Mars. Now this is something we can't really prove right now, but this finding itself warrants for a mission here. We definitely have to go and investigate and try to recover some of the samples from this rock in order to find out if this is indeed a sign of a previous collision from the moon. And if that's the case, we might be able to discover some other unusual mysteries about the history of the moon and, of course, planet Earth as well. And because getting to these asteroids isn't really that much more difficult than getting to asteroid Bennu or asteroid Ryugu, it's definitely something we can technologically achieve in the next few years, assuming of course there's interest. But first we definitely need more confirmation and more follow-up studies trying to investigate what exactly is happening with this particular rock and find out if it has any other relatives somewhere in the vicinity as well. For all we know, there could be a whole family of these lunar asteroids orbiting somewhere out there, not so far from planet Earth and not so far from Mars. But I guess until we discover something else about this unusual rock, or until we discover the actual origins of all of these other asteroids, that's all I wanted to mention in this video. Check out the paper in the description below, subscribe if you still haven't, share this with someone who loves learning about space and sciences, and maybe come back tomorrow to learn something you may have not known before. Also, maybe support this channel on Patreon or by buying the Wonderful Person t-shirt that you can find in the description below. I'll see you tomorrow, space out, and as always, bye bye.